Hello everyone, in this video we are going to look at motion of a vehicle on a curved path. Now the guiding question in this discussion is as follows. Forces acting on a vehicle that rounds a curve of radius r at a velocity v when turning left on a track banked at an angle theta are as shown below. This is a vehicle that is moving on a curved path where the track is banked at an angle theta. Then these are the forces that are acting on the vehicle. This r is the radius of the curved path. V is the velocity of the vehicle as it moves around that path. Name the forces marked P, Q, and R. Show that also, this is the second equation, show that the required angle of banking to eliminate lateral forces on the tires is given by tan theta v squared out of gr. Let us look at the answer to this particular problem. This is the body, the vehicle, being acted upon by these forces as it negotiates this curved path where the track is inclined or is banked at an angle theta. Now, when we look at this body, we know that this is motion on a curved path. P is always the force due to the weight of the vehicle, and it is equal to mg. Then Q is the centrifugal force that tends to throw the vehicle out of the circular path, and it is always equal to mv squared out of r, whereby m is the mass of the vehicle, v is the speed at which it is moving, then r is the radius of the path. Centrifugal force is acting in opposite to the centripetal force, because centripetal force act, of course I'm trying to mean something like this. Centripetal force is the force that is trying to keep the body moving around this path, around the curve, but there is always a force that acts opposite, that is equal and the opposite to this force, centripetal, that tries to pull the vehicle out of the circle, and this is always called centrifugal. Then this one is centripetal. Now R is the normal reaction due to the weight of the vehicle. Remember, this R is always, if we are to have these tires experiencing a normal reaction, then the resultant of this P and Q must always be normal to the path and therefore normal to the body itself. Therefore, this is going to be the normal reaction due to the weight of the vehicle. So let us look at part 2 of this question, where by tan theta is equal to v squared out of rg. Considering the motion of this vehicle on a curved track, then we have an assumption of this body on moving on an inclined plane. So this is the angle of banking, and it is always provided where the road is in a corner, and it is always to ensure stability of the vehicle and safety of the vehicle. Therefore, as it negotiates that corner, always is to ensure that there is the resultant of the centrifugal force and the weight of the body is always normal to the path where the tires of this vehicle are. Therefore, this is the angle of banking. W is the weight of the body. You remember, motion on an inclined plane, this W will always have a component W sine theta, which is along the inclined plane due to gravity, and it will always have a normal reaction, another component equal to the normal reaction, which is W cos theta. And remember, this is the centrifugal force that is always pulling the vehicle out of the circle. So if I create a line parallel to this horizontal that cuts this inclined plane, then this theta is going to, this angle here is also going to be theta. These are alternate angles, and therefore we can say this angle here is equal to this angle here. Now if I expand more, it means I have theta here, I have theta here, I can create theta here. Then remember this is 90, of course. Now this angle remaining here is 90 minus theta. This becomes theta also. This becomes 90 minus theta. This is theta. Therefore, if I consider forces along the inclined plane or parallel to the inclined plane, when I resolve those forces, I will have W sine theta. If I resolve this force, this will be W cos 90 minus theta, which is equal to sine theta. So it will be W cos 90 minus theta, which becomes W sine theta. That's why I have it here as W sine theta. Then it will equal to F cos theta. Remember, F is horizontal, therefore it will remove through an angle theta to realign with this W sine theta, and therefore this W sine theta will equal to F cos theta. So therefore W sine theta divided by cos theta is equal to F, and I can have, you remember, this W is the same as weight of the body and is equal to mass times acceleration due to gravity. It is equal to mg. F is the centrifugal force, which is equal to mv squared out of r. And if I call this equation A, I call this equation B. So from equation A and B, if I combine these two, I will have mg sine theta out of cos theta is equal to mv squared r. And remember, this sine theta out of cos theta is equal to tan theta. Therefore, tan theta is equal to v squared out of rg. Remember, if it is mg times the sine theta out of cos theta, and is the I cancel this m and m, then I will have this r move this way, so that I have rg tan theta, remember, is equal to v squared. So if I divide both sides by tan theta, v squared out of tan theta, then I will have rg equal to v squared out of tan theta. So if I bring tan theta this way, I will have tan theta equal to v squared out of rg, and this is as required. Thank you so much.